In our previous lesson, we were talking about calculating the average rate of change. And we're going to continue with that, but we're also going to see, again, if the average rate of change is consistent or constant. That means no matter where you're calculating it with 2 points, it is always the same. We refer to that as slope. So remember, the slope is talking about the ratio of the vertical change to the horizontal change. Vertical, again, that's how it's going up or down, to horizontal, left or right. Vertical is also referred to as the rise and horizontal as the run. Or change of y, that's your vertical, the rise, as your change in x, your horizontal, the run. How steep is your line? So again, slope is referred to by all of these terms. Rise over run, change in y and change in x. And we have notation that also represents the change in y and change in x, which is delta, so it looks like a triangle. So this is the change in y over the change in x. So with that in mind, we want to practice identifying some slopes, okay? And we've got our 3 representations here. So let's take a look at a couple of graphs and see if we can find the slope. So here we have the graph on the left. And again, we always want to find 2 points on it to calculate the slope. And notice how you have several points on the line, and we're looking for points that are grid lines, points that the coordinates are known. So what I could do for the one on the left is start at the y-intercept and see how it takes me to travel to the next point. So starting at the y-intercept, if I go up 2 units and over to the right 3 units, I get to my next point. And notice how it's consistent from point to point, always up 2 and to the right 3. If I didn't want to start at the y-intercept, I could have started at another point here, and again, the pattern is the same, going up 2 and to the right 3 each time to find our point. So the rise over run, the change in y over the change in x, the change in your vertical versus your horizontal would be 2/3. And again, it's consistent throughout your line. So the slope is 2/3. So now let's have you try the second graph. Can you calculate its slope? So again, I could start at the y-intercept, say how am I going from point to point? Here I'm going down 2 units into the right 1, down 2 in the right 1, down 2 in the right 1. No matter what point I started with on my graph, I'm always going down 2 and to the right 1 unit. So again, since we're going down, that's a decrease, so we'd have -2 over 1, which would be -2. So my slope is -2. So let's try some more. And again, we know lines have infinite points, and so you want to pick grid points to calculate the slope. So let's give you a moment and see if you can calculate the slope for the graph on the left and the graph on the right. So the graph on the left, we want to use some grid points. So again, I have a y-intercept here, and I have another point here. Now notice I don't travel up or down to get to the next point, so my change is 0. But I would go to the right 5 units to get here. So the change in y over the change in x, 0 over 5 is 0. No matter where I put my 2 points, the change in y would always be 0. And we know that when you have 0 divided by a number, your answer is always 0. So our slope for the graph on the left is 0. This would be true for any horizontal line where there is no change to go from point to point vertically. Your slope is always 0. Now for the graph on the right. Again, just to have a starting point, let's use the x-intercept this time. And we need another point on the line. Let's pick this point here. Again, the change in y over the change in x. So I'm going down 6 units here. And I'm not going to the left or right any to get to this point. So if I do -6 divided by 0, what do we end up with? Well, I can't take something and put it into nothing. That's undefined. So this slope would be undefined. No matter where I put the second point, I would only be traveling up or down, but not left and right. And we know anything divided by 0 is not possible, therefore it's undefined. So a vertical line has an undefined slope. So these are two items that we want to keep in mind going forward. A horizontal line always will have a slope of 0, and a vertical line will always have a slope that is undefined. So we start off with a graph. We can do the same thing with the table. We want to see the rate of change from point to point. So let's see how the inputs are changing compared to the outputs. So the one on the left, we can see that there would be no change in the inputs. These would always be 0. Then we can see the change in the outputs. So remember, it's current divided by previous, current minus the previous. So we have this minus this, this minus this, this minus this for your rate. Now, it's always the change of the output to the input. So 8 divided by 0, 3 divided by 0, 17 divided by 0. We know anything divided by 0 is undefined, so that would be our slope. So here's a tabular representation of what a vertical line looks like. The inputs are all the same, the outputs are different. So remember, the rate of change of the input being 0, that gives you the undefined slope. So let's give you a minute to take a look at the table on the right. Could you calculate the slope for this set of data? Again, look at the rate of change for the inputs and outputs, and then we compare the rate of change from the output to the input. So 1 minus 0, that would be 1. 3 minus 1 is 2. 4 minus 3 is 1. Then you're doing the current minus the previous for your changes for the output. So we would have our -2, -4, -2. So now that we have the changes, we're going to compare them. -2 over 1, -4 over 2. Well, that's -2. -2 over 1. You have a consistent change of -2 over 1, which is saying your slope is -2. That means graphically you would be going down 2 and to the right 1 to get each of your points. Let's try a couple more from a table. Let's give you a minute to find the slope for the table on the left. Again, we're going to look at the change of the inputs, the change of the outputs, and then compare them. And it's always the current minus the previous. Current minus the previous. So -3 minus -4 would be 1. 1 minus -3 is 4. 4 minus 1 is 3. Same thing for the outputs. -5 minus 5, 0. -5 minus -5 is 0. -5 minus -5 is 0. Remember, when you're subtracting a negative, it tells you you're doing the opposite. That would be a positive. That's why we have the zeros. So we have the changes for the inputs and the outputs. Now we compare them. 0 over 1, 0 over 4, 0 over 3. 0 put into any groups is always 0. So our slope here is 0. This is what a tabular representation for a horizontal line would look like. The outputs are all the same. That's why we have the slope of 0. So let's give you a moment to try finding the slope to the table on the right. Again, we're going to do the change of the inputs comparing to the change of the outputs. Starting with inputs, -2 minus -4, that's -2 plus 4, which is 2. 0 minus -2, that turns into 0 plus 2, which is 2. 4 minus 0 is 4. Okay, do the change of the outputs. -3.5 minus -5, that turns into a positive 5. That gives us a 1.5. -2 minus a -3.5, remember the saying, take the opposite. So -2 and 3.5 gives you 1.5. 1 minus -2, that gives us 3. So we've got the change of the inputs, we have the change of the outputs. Now we compare them. 1.5 over 2, 1.5 over 2, 3 over 4. Now, typically, we don't have decimals within the fraction. So let's double this amount to eliminate the decimal. 1.5 and 1.5 is 3. Double this, 2 and 2 is 4. It's 3 over 4. Same thing here, 3 over 4. Our constant rate of change is 3/4. That is our slope. So we know how to find the slope graphically, making our triangles, talking about the rise over run. We know how to find it tabularly, looking at the change of the inputs and outputs, always taking the current minus the previous, and then we compare the changes to get our ratios. Now, if we just are given 2 points, we should also be able to find the slope between them. Again, looking at the change of the outputs to the inputs. So when we have coordinates like this, 3, 2, and 1, 6, we have an x and a y and an x and a y. Remember, the change of the outputs is the difference of the y's, and the change of the inputs is the difference of the x's. So what we would do here is take the difference of the y's and compare them to the difference of the x's. So let's say I'm just going to start with this point. So the difference of the y's, 6 minus 2 is 4. And since I started with this point, I have to do that for the x and the y. So 1 minus 3 is negative 2. Always simplify to get your slope accurately. So if you have 4 divided by negative 2, that would be negative 2 for your slope. Well, what does that mean? To get from each point on your line, you're going down 2 and to the right 1. So let's find the slope between these 2 points, 1, 5 and negative 3, 5. Again, we're going to find the change in the outputs, the y's, over the change of the x, the inputs. So let's say I start with our point here on the right, negative 3, 5. So we go 5 minus 5 over negative 3 minus 1. Well, we know 5 minus 5 is 0. And negative 3 minus 1 is negative 4. To simplify, 0 divided by negative 4 is just 0. So our slope is 0. And again, we might have noticed that because the outputs were the same values. Remember, when those outputs were the same, there was no change vertically. So it's a horizontal line, therefore our slope is 0. All right, let's try a couple more. If you're given the coordinates negative 2, negative 6, and negative 2, 4, can you find the slope that passes between them? And what if you have the coordinates negative 2, 2, and 4, 5? Can you find the slope for those? So the one on the left, again, we're going to do the change in the y's over the change in x. The outputs compared to the inputs. So let's say I start with our point here. 4 minus negative 6 over negative 2 minus negative 2. Again, subtracting a negative is like adding a positive. It's telling you to take the opposite. So 4 and 6 is 10. Negative 2 and 2 is 0. Again, we know we cannot divide by 0, therefore it's an undefined slope. Perhaps you noticed that without doing the calculations, that since the inputs were the same, that would have to make it a vertical line, and you know the vertical lines have undefined slopes as well. So if you wrote that as your explanation as opposed to doing the calculations, that would still be a correct answer. For our 2 points here in example 8, again, the change of the outputs to the inputs. So let's start with our second point here. So change in y, 5 minus 2, over our change in x, 4 minus negative 2. Well, 5 minus 2 is 3, and 4 minus a negative 2, remember that's taking the opposite. 4 plus 2 is 6. Again, try to simplify. 3 is the greatest common factor for each of those we could divide out, so our slope would be 1/2. What does that mean? To get from point to point on your graph, you go up 1 unit and to the right 2 to create its next location. So now it's your turn to practice calculating the slope, whether given 2 points coordinates, whether given a table of points on a line, or given a graph of a line. Find its slope, always put it in simplest terms, and remember that when you are dividing by 0, that's undefined, a vertical line. If you have 0 being divided by a number, that's a horizontal line. The slope would be 0.